Measuring customer satisfaction with market research data. In this lesson, we will learn how to analyze customer satisfaction survey data for actionable business insights. Customer satisfaction is crucial for building loyalty, improving retention, and informing marketing strategies. By the end, you will know how to measure, visualize, and segment satisfaction scores using real datasets. We will solve problems relevant to customer analytics and market research teams. Running the cell now. We import OpenML to fetch public survey datasets. We import pandas for data manipulation and quick summaries. We import NumPy for common numeric operations and to set random seeds. We include matplotlib for simple data visualizations and charts. We import Seaborn for advanced plotting and quick comparisons. Finally, we import warnings to suppress irrelevant warnings for a clear analysis. Running the cell now. Understanding customer satisfaction data. Most customer satisfaction datasets use structured responses from surveys. Columns often include demographics, like age, gender, service indicators, and satisfaction scores, like NPS or Likert ratings. Be careful, missing data, incorrectly coded scales, or reverse scales are common mistakes for beginners. Always verify what each score means before analyzing, and watch out for leading or bias survey questions. Running the cell now. Let us load a real customer satisfaction survey dataset from OpenML. We begin by getting a real customer satisfaction dataset for our analysis. We fetch the dataset from OpenML using its unique ID. We extract the main data as a pandas data frame to work with. Here we print the dataset shape so we know how many records we have. We preview the top 3 rows to see the structure of our customer responses. Running the cell now. This output shows the customer satisfaction dataset loaded with 7,043 rows and 20 columns, giving us a wide range of demographic and service-related variables. The first 3 rows illustrate key columns like gender, tenure, service options, and churn status, which are essential for understanding customer behavior and satisfaction trends. Notice how this step confirms the data's structure and readiness for deeper analysis, a crucial first move to avoid pitfalls like missing or misinterpreted variables. Practice: try printing the column names to see what kinds of survey responses were collected. Next, let us check if we have any missing survey responses or demographic values. It is important to check for missing values in each column before starting our analysis. Here, we count the number of missing entries for each column. We display only the columns with missing data, so we know where to investigate further. Running the cell now. This output shows that there are no missing values in any columns of the customer satisfaction dataset, as indicated by the empty series. This confirms the data is complete for all surveyed questions, allowing us to proceed with analysis without needing to handle missing responses. Checking for missing values is a crucial first step to ensure the quality and reliability of survey results. Beginner tip: always handle missing data before you compute satisfaction scores or trends. Demographics help us understand which customers are included in the survey and potential biases. We count the number of survey respondents by gender to see the gender split. We also count how many survey respondents are classified as senior citizens, which can affect satisfaction trends. Running the cell now. This output shows the distribution of customers by gender and senior citizen status in the dataset. Notice that the counts are fairly balanced between males and females, but there are many more non-senior customers than seniors. This summary helps verify demographic columns before diving deeper into satisfaction analysis and ensures we understand the sample composition. Practice: try visualizing another demographic feature using value_counts. Let us visualize how many customers churned as a simple satisfaction indicator. We create a count plot to see the distribution of customers who churned versus those who stayed. The plot helps us quickly see the number of satisfied versus dissatisfied, churned, customers. We label the x-axis to show if the customer churned. We label the y-axis so counts are clear. We display the chart to make it easy to compare satisfaction at a glance. Running the cell now. This bar chart shows the count of customers who have either churned or stayed, using churn as a proxy for satisfaction. Notice the balance or imbalance between these two groups, which helps us understand overall satisfaction trends in the dataset. Visualizing churn this way is a key step for beginners to connect behavioral outcomes with survey responses in customer satisfaction analysis. Business insight: high churn usually signals lower satisfaction. Where does your business stand? The churn rate estimates the percentage of dissatisfied customers in your dataset. We calculate the churn rate as a percentage of customers who left. We print the churn rate for the business to understand its magnitude. Running the cell now. This output shows that 26.54% of customers in the dataset have churned, meaning they stopped using the service. This simple calculation helps us quickly gauge customer retention levels, which is crucial before diving deeper into satisfaction scores or demographics. Noticing this churn rate early on sets the stage for targeted analysis, like exploring factors that influence why customers leave. Practice: calculate churn rates for subgroups such as by senior citizenship or monthly charges. Next, let us examine direct satisfaction scores with a synthetic but realistic NPS dataset. We set a seed for reproducibility so our survey results are identical each time. We create a data frame representing 500 customer responses, each with an NPS score from 0 to 10. Each record includes a customer ID for tracking individual responses. We include age to segment insights later. The region variable allows for comparing regional performance in customer satisfaction. We print the top records to verify our NPS dataset structure. Running the cell now. This output shows the first 3 rows of a synthetic Net Promoter Score (NPS) survey dataset with 500 customers. Notice the structure includes customer IDs, ages, regions, and NPS scores ranging from 0 to 10, which is typical for NPS data. This example sets the stage for exploring how demographic and regional factors might relate to customer satisfaction scores, emphasizing the importance of understanding the data's format before analysis. NPS, Net Promoter Score, is a gold standard in customer satisfaction. Learn more on YouTube. Visualizing NPS scores reveals satisfaction trends instantly. We create a histogram to visualize how NPS scores are distributed across all survey respondents. We add a descriptive title so business users know what is shown. We clarify the x-axis to indicate the NPS score scale from 0 to 10. We clarify the y-axis for the number of responses per score. The chart lets us see if most customers are promoters, passives, or detractors. Running the cell now. This histogram shows the distribution of NPS scores from 0 to 10, highlighting how many respondents gave each rating. Notice any peaks or gaps, which reveal overall customer sentiment trends, such as clusters of promoters 9 to 10, passives 7 to 8, or detractors 0 to 6. This visual check helps confirm the data's range and frequency before further analysis, ensuring scores are correctly coded and meaningful. Practice: can you spot if your business has mostly promoters or detractors? A single number, the NPS, summarizes customer loyalty and satisfaction. We count all survey responses to use as our NPS denominator. Promoters are those with scores of 9 or 10, very satisfied customers. Detractors are those with scores 6 or below, likely to share negative feedback. We calculate the classic NPS formula, promoters minus detractors, divided by total, multiplied by 100. We print the resulting Net Promoter Score, which can guide loyalty strategies. Running the cell now. This output shows a Net Promoter Score of -47.6, indicating more detractors than promoters in the customer responses. Notice how the code counts promoters, scores 9 or 10, and detractors, scores 6 or below, to calculate this percentage, which helps summarize overall customer satisfaction. This step is essential for interpreting survey data, especially to identify service areas needing improvement or to verify the correct use of scoring scales. Try adjusting the thresholds to see how NPS changes for your customers. Segmentation shows if different customer groups have distinct satisfaction levels. We calculate the NPS separately for each region group. For each regional subgroup, we apply the NPS formula. The result is a NPS score for each region, showing which market areas need attention. We print the NPS by region for the business to compare performance. Running the cell now. This output shows the Net Promoter Score, NPS, segmented by region, revealing negative scores across all areas, which indicates more detractors than promoters. Notice the variability in how each region's customers perceive the service, with the South and East scoring the lowest. This step highlights the importance of breaking down satisfaction data by key demographics to uncover regional differences that might require targeted improvement efforts. Business tip: regional managers may want to know why NPS is higher or lower in their areas. A chart comparing NPS by region helps managers take targeted action. We plot our region NPS results as a bar chart for easy comparison. We title the plot to clarify it shows Net Promoter Scores by region. We label the x-axis with each regional group. We label the y-axis with NPS values. We set the y-axis range for standard NPS between -100 and 100. We show the chart so business teams can see strengths and weaknesses at a glance. Running the cell now. The bar chart displays Net Promoter Scores, NPS, across different regions, allowing us to compare customer loyalty geographically. Notice the height of each bar indicates the strength of positive or negative sentiment, with scores ranging from -100 to 100. This visualization helps identify regions with particularly high or low customer satisfaction, guiding targeted improvement efforts. YouTube tip: learn more about segmenting customer satisfaction on our channel. Open-ended feedback gives qualitative context for your satisfaction scores. We create a small data frame with customer IDs and their qualitative feedback. The feedback column contains open-ended comments directly from customers. Previewing this data helps managers hear the voice of the customer, not just the numbers. Running the cell now. This output shows a small sample of open-ended customer feedback data, with each row linking a customer ID to their written comments. Notice the variety in sentiment and topics, highlighting how qualitative feedback complements numeric ratings in understanding customer satisfaction. This preview is essential to verify the data structure and prepare for techniques like text analysis or sentiment scoring later in the lesson. Practice: try adding your own text feedback and see what insights you can extract. Sentiment analysis allows us to quickly classify customer opinions as positive or negative. We use a keyword search to flag feedback as positive if it contains certain words. Comments not matching trigger as negative for initial screening. We print both the original feedback and our sentiment labels for the business to review. Running the cell now. This output shows a new column: sentiment, classifying customer feedback as positive or negative based on specific keywords. Notice how phrases containing positive words like great or excellent are correctly labeled positive, demonstrating simple keyword-based sentiment detection. This highlights a key step in transforming qualitative survey text into structured data for further satisfaction analysis. Practice: add neutral labels or expand keywords for improved detection. Cross-tabulation helps discover which services relate to customer churn, a proxy for dissatisfaction. We build a crosstab to relate churn outcome by the type of internet service the customer uses. Normalization by index turns counts into percentages, which are easier for managers to interpret. The resulting table shows the percent of churned customers for each service type. Running the cell now. This cross-tabulation shows the percentage of customers who churned or stayed, broken down by internet service type. Notice that fiber optic users have the highest churn rate, 42%, while customers without internet service show the lowest churn, 7%. This highlights how specific service types correlate with customer retention, emphasizing the importance of segmenting satisfaction and churn analysis by key service indicators. Business insight: service-specific churn analysis reveals where product improvements are needed most. Trend analysis uncovers when dissatisfaction peaks during the customer life cycle. We create a new feature to group customers by month since their sign-up. We calculate the percentage of churn for each monthly group. We plot the churn rate over time to visualize peaks and valleys. We title the chart to explain the insight shown. We label the x-axis for sign-up month and y-axis for churn rate percent. The plot reveals when satisfaction is lowest and retention strategies may be needed. Running the cell now. This line plot shows the trend of churn rates for customers based on how many months they've been signed up, with each point representing the percentage who churned that month. Notice the shape of the curve and whether churn increases, decreases, or fluctuates over time, which can reveal critical periods where customer satisfaction or retention efforts should focus. This analysis connects to the lesson by using a service indicator column, churn, over time to highlight patterns beyond static satisfaction scores, emphasizing the need to carefully interpret derived metrics like monthly churn rates. Practice: try grouping by another time period or feature to spot different trends. A custom satisfaction index combines behavioral and service data for advanced analysis. We create a new metric dividing monthly charges by tenure to reflect cost stability over time. We assign this value as a new column in our dataset. We print the components and the score to see how our index works for the first few customers. Running the cell now. This output shows how the satisfaction index combines monthly charges and tenure into a single metric by dividing charges by tenure when tenure is non-zero, otherwise using the monthly charge directly. Notice the large index values for short tenures, rows 0 and 2, indicating higher charges per month of service early on. This step helps highlight potentially dissatisfied customers with high relative costs, aligning with the lesson's focus on creating meaningful, interpretable satisfaction measures from raw survey and billing data. Index scores help compare satisfaction trends at scale. Now we perform median imputation for selected numeric columns. First, we create a copy of the original data frame to avoid modifying it directly. We define the list of numeric columns that require cleaning. Next, we convert the selected columns to numeric format. We set errors equal to coerce so invalid values become missing values. We close the numeric conversion block. We then replace missing values using the median of each column. We calculate the median for the selected numeric columns. We close the filter operation. Finally, we verify that there are no remaining missing values. Running the cell now. This output confirms that all missing values in the total charges and monthly charges columns have been successfully filled with their respective medians, as shown by the zero null count. This step is crucial to ensure numeric service indicators are complete and reliable before analyzing customer satisfaction trends, preventing bias or errors caused by missing data. Median imputation is robust to outliers and often preferred over mean imputation. In advanced workflows, we may use imputation pipelines inside scikit-learn for automation. Spelling errors are common. Get column names right to prevent faulty groupings. We attempt to group by a misnamed column, which will trigger an error. If the column is misspelled, we print a diagnostic message. Always verify column spelling before analysis. Helpful error messages guide users to correct mistakes quickly. Running the cell now. Here, the code attempts to count survey responses grouped by gender, but it fails due to a column name typo. This error handling reminds us to verify column names carefully, a crucial step since small mistakes can halt analysis and obscure trends in demographic groups, key for understanding how satisfaction varies across customers. Tip: run df.columns to inspect column names before grouping. Invalid satisfaction scores can appear from data entry errors, especially for NPS or ratings. We define a function to recode and validate every NPS score. Any score outside 0 to 10, or with invalid format, is set as missing. We apply the function to our NPS column, correcting errors. We print the count of invalid or missing NPS scores after cleaning. Running the cell now. This output shows that after applying the recode_NPS function, there are 0 missing values in the NPS_scores column, indicating no invalid or out-of-range scores remained. This confirms the code successfully caught and handled any miscoded NPS values, which is crucial before analyzing satisfaction trends to avoid biased results. Clean data reduces misleading satisfaction insights. Best practices for customer satisfaction analytics. Segment and compare satisfaction by key demographics or behaviors. Use cross-tabulation for quick two-way comparisons, for example, product versus churn. Always standardize rating scales so everyone is measured on the same terms. Trend analysis over time highlights critical moments in the customer journey. Build indices when simple single-question scores are not enough. Running the cell now. Segmentation quickly reveals what customer groups are most at risk of dissatisfaction. We use cross-tabulation again, this time segmenting by contract type. Percentages by contract show where the risk of churn is highest. Managers can use this segmentation to tailor loyalty programs. Running the cell now. This table shows churn rates segmented by contract type, clearly revealing that month-to-month customers have the highest churn at about 43%, while longer-term contracts show much lower churn. Notice how the code normalizes by contract to give percentage breakdowns, making it easier to compare satisfaction or churn behavior within each segment. This cross-tabulation is a powerful best practice for quickly identifying which groups need targeted retention efforts. Try segmenting by payment method or other customer attributes. Index scores help compare satisfaction across different variables and create benchmarking metrics. We create normalized indices for both monthly charges and tenure to remove scale effects. Dividing by the column maximum puts all values between 0 and 1 for easy comparison. Now, customers can be benchmarked on fair terms, even with different plan sizes. Running the cell now. Here, we see the creation of two indices, charge index and tenure index, that standardize monthly charges and tenure by dividing each value by their respective maximums. Notice how the scaled values fall between 0 and 1, allowing for fair comparison across customers regardless of the original scale. This approach supports advanced benchmarking by transforming raw metrics into comparable indices for deeper customer satisfaction analysis. Construct your own indices for any pair of relevant business variables. Here we solve a real market problem. What % of your high-value customers are truly satisfied and likely to recommend you? We reload the customer satisfaction survey to ensure a clean dataset. We fill in missing monthly charges as before. We use churn as a rough proxy for NPS, treating non-churned as promoters and churned as detractors. We select customers whose monthly spend is above the median. These are high-value customers. We calculate the percentage of high-value customers with proxy NPS of 9 or higher. We print the result as a key recommendation for the business. Running the cell now. This output shows that about 65% of high-value customers, defined by above-median monthly charges, are classified as promoters using a churn-based NPS proxy. Notice how the code segments customers by spending and maps churn to a satisfaction scale, highlighting the importance of combining behavior and satisfaction metrics to identify key customer segments. This approach aligns with best practices for targeting insights where simple scores may not fully capture customer value. Recommendation: focus on keeping high-value promoters happy to maximize ROI.